Okay guys, well if you're still watching, thank you. Sorry, I talked too much in the last video, so I ran out of time basically, so I needed to make a new one for just this last example. It's quicker because by now we've explained it twice in the previous two examples, so this is just to make sure we're really good to go with the practice. Okay, so last example here. First thing I think about is, can I do the easy way? Do I have one fraction equal to another fraction? I sadly don't, right? Because here are two, it doesn't look like this is a fraction, right? But I could make it a fraction by putting it over 1. So I don't have one fraction equal another fraction, which means the process that I have to go back through is the one that we just did here, where I need to get rid of those fractions. How do I get rid of the fractions? Is I get a common denominator and then multiply each side of the equation by the common denominator. Okay, so I look at this. My denominators are already in simplest form, right? I don't have to factor all my denominators, so I could just look at it and know what's my least common denominator, x minus 2. While I do that, remember, I also want to think about my domain for those extraneous solutions that may come up. So my least common denominator is x minus 2. My domain is x cannot be 2. Okay, what do I do with this least common denominator? Is I need to take it and multiply my entire equation by my least common denominator. So I take my entire equation, put it in parentheses, multiply x minus 2 by everything. So I hope you're still watching, because this is where I don't really write out this distributing every time, because, I mean, we're honors, we really don't need to be doing that. When I take x minus 2, distribute it to this first fraction, I need to just look at it right here and realize, well, x minus 2 and x minus 2 are going to cancel. So I'm going to be left with 5x, my numerator. Again, here, 7 over 1 times x minus 2, nothing cancels. It's just a whole number. I'm going to have 7 times x minus 2. And then plus 10 over x minus 2 times x minus 2, that x minus 2 is going to cancel, and I'm going to be left with 10. If you need to obviously write it out on the side, go for it, but I hope that we'll be able to get to a point where I see that this is just going to cancel with anything in my denominator. And if it doesn't, it's going to be multiplied with the numerator, like with that 7. Okay? Once I get rid of my fractions, this is basic algebra. How do I solve for x? First, I'll distribute this 7 to everything. Right, so I'll have 7x minus 14 plus 10 equals my 5x. I'm going to combine like terms, right? So I do negative 14 plus 10 is negative 4. I'll get my x's together. So I subtract 7x on both sides, gives me negative 2x equals negative 4. Get that x alone by dividing by negative 2. X equals 2. Okay, but wait a second, I need to check that solution with the original equation, because check that out, didn't we say x could not be 2, right? But I just said x equals 2, because I've manipulated. I bet some of you are asking, why do I even get an answer like that? Is because all throughout this, I've manipulated my original equation. I've changed it, okay? I've multiplied things to both sides. I've altered it. So it's a solution, but it's really impacting this denominator. So for that reason, it is not a solution. This equation has no solution. Okay, so I could say my final answer, my final solution is no solution, does not exist, however you want to write it. Okay, I hope you guys stayed with me for this third example in the second video. That's all. You're going to go ahead and try all of those try-its in the practice section. You guys rock. Awesome job.